Good morning. In previous lecture, we have seen what is the importance of HDL language, types of HDLs like VHDL and Verilog, different design units of VHDL like entity declaration, architecture body, package declaration, package body, configuration specification. Also, we have written the entity declaration and architecture body for half an order. Now, in this lecture, I would like to discuss some basic elements like identifiers, data objects, data types, operators. Coming to identifiers, actually already we discussed about the identifier. What is identifier? Identifier is a group of characters including all alphabetic letters, digits 0 to 9 and only underscore you can use. What is the purpose of this identifier? It is used to name different design units and also objects like constants, signals, variables, etc. Certain rules you need to follow for the identifier, right? Then coming to data objects. What is a data object means? To hold certain value of a specified type. The purpose of data object is to hold a value of a specified type. Type is what type of data like that. Integer data, character data. That is the meaning. Okay, the purpose of object is to hold a value of a given type or specified type. In the language, there are four different classes of data objects are available. Those are constants, variables, signals and files. Okay, so let us see one by one. First of all, come to constant data object. The constant data object can hold a single value and the assignment of value can be done before the simulation process. While simulation process, the value of this constant object cannot be changed. That means it is fixed. And how can you declare a constant object means with the help of constant object declaration statement. Let us see the syntax of constant object declaration. It starts with the word constant, constant name, type name, colon equal value. That is, here constant name is, this is identifier. Constant name is the identifier, that is user defined name, colon type name. Here type name, type represents the what type of data the constant object can hold. Okay, colon equal value. So here you need to place the value which you like to assign to the object constant. Okay, so let us see some examples for this constants. Here two examples are represented. One is, first example is constant rise time colon equal 10 nanoseconds. Means rise time is an object of class constant which hold which type of data? Time type of data. Time type of data the rise time can hold. And its initial value is 10 nanoseconds. Initial value is 10 nanoseconds. Initial or what? Whatever. The value once assigned that may not change. Okay. And the second example is constant bus width colon integer colon equal 8. That means bus width is a data object of which class? Constant class. Of constant class can hold which type of data? Integer type of data. Integer type of data. Here how much value we assigned? 8. The value 8 is assigned to the object bus width. Okay. Then coming to variables. The variable also can hold a value of a specified type, but the value can be changed during the simulation process, and the assignment can be done using variable assignment statement. The value is assigned to a variable object by variable assignment statement. Let us see the syntax of variable data object. Okay, start with variable word, the word variable name, colon, type, and optional one is colon equal initial value, colon equal initial value. Okay, initially you can assign a value or not. Okay, so here again the variable name is, that is identifier. Variable name is the identifier, colon, type. Type is what type of data again. Okay, let us see some examples for this variables. The first example here is variable found comma done of type boolean. Okay, here found is a data object of class variable. Similarly, done also a data object of class variable, which holds which type of data? Boolean type of data. That is, boolean is a predefined data type. Boolean is predefined data type. It consists two values, true and false. Only those two values this object found or done can be accepted. And coming to second variable declaration, variable name is sum, colon, data type is integer, range 0 to 100, colon equal 10. Okay, that means sum is an object of class variable. Which data type it is? It can accept integer data type. That too in the range is 0 to 100 only. Okay, the value of integer which is accepted by sum is must be in the range 0 to 100. Okay, so initial value is 10. Then coming to third declaration, variable control status. Control status is an object of class variable. Which data type? Bit vector. Bit vector means the control status is declared as an array. Array with how many locations? 11 locations. Okay, 11 locations. Each location can accept which type of data? Bit type of data. Okay, so like that variables can be declared. Then coming to signals, the signal also can hold a value of a specified type, and for the signal also the value can be changed during the simulation process, and the value can be assigned to the signal object by signal assignment statement. Signal assignment statement. Then coming to syntax, similar to previous ones, it starts with the word signal followed by signal name, colon, type name, and optional one is assigning initial value. This is the optional one. Okay, whichever is placed in square bracket usually represents the optional. Okay, so here also signal name is identifier or user defined name. Type represents the what type of data. Let us see some examples. So the first example implies X is an object of class signal. It can access bit type of data. Okay, that to single value. Okay, single value only. That is, bit is predefined data type. It has two values, 0 and 1. So X can accept either 0 or 1 at a time. Okay, 1 bit at a time. But coming to second declaration, signal Y colon bit vector of 1 to 5. That means Y is an object of class signal, but the Y is declared as array. Array with how many locations? 5 locations. 1 to 5 means 5 locations. Each location can accept what type of data? Bit type of data. That is, here Y can accept more than 1 bit. More than 1 bit. In previous case, the bit X can accept only 1 bit at a time, whereas Y can accept how many bits? 5 bits. Okay, so 5 bit data you can assign to this Y. Okay, similarly the third example also it declares y as array with 7 locations. With 7 locations, each location type data is bit. Okay, so like that signals can be declared. Then coming to fourth one, that is file. The purpose of file is to hold a sequence of values. To hold a sequence of values. Let us see the syntax of file is start with the word file, file name, colon, file type name. Here it is file type name. And optional ones are open mode is string. Okay, so as usual, file name is a user defined name. File type name is what type of data the file consists. Open mode. Mode is, here we have two modes. One is read mode and another one is write mode. So the file is opened in either in a read or write mode. Is string expression. String expression represents the path of that file. Okay, where it is exactly located in the host environment. Okay, for example, if you see one example for this file declaration, file, its name is vectors. The file name is user defined name is vectors. Data type is bit file. Data type is bit file. Open read mode. Read mode. That means we can only extract data from this file, and it is located in the path like this. Okay, so like that you can declare files. Okay, so out of all, if you see, the purpose of signal is to model the wires of a digital circuit, whereas constants, variables and file usage is same as in the higher level languages like C or Pascal. There also we have the variables, constants, files, etc. What is the action in those languages? The similar action you can observe here also, but except for the signals. Signals are used to model the wires. Okay. Then coming to data types. So already you know data type is what it represents the type of data which is going to be loaded. Okay. So with reference to types, there are already some predefined data types are available in the language. User also can define his own data type by using an instruction type. Okay, just type. Let us see some predefined data types. Say those are bit, bit vector, boolean, character, integer, real, string, time, standard logic, vector. These are the some of the predefined data types. Okay, so coming to bit, the bit consists two values, only 0 and 1. So the object whichever declared under data type bit, that object can accept either the value 0 or 1, but only one bit at a time. Instead of bit, if you assign bit vector, automatically that object is created as an array, and it accepts more than one bit value, more than one bit data. Suppose if the data type is boolean, the boolean consists two values, true and false. So only that object can accept either boolean or true. Either true or false. Okay, so like that, the other predefined data types are this. Then coming to how the user can define his own data type means. So let us see. User defined data types are 4 classes. Those are scalar types, composite types, access types, file types. Coming to scalar, again the subclassification here is enumeration type, integer type, floating point and physical. Okay. Under scalar, there are four categories: enumeration type data type, integer data type, floating point data type, physical data type. Coming to enumeration data type, the enumeration data type includes the values in the form of identifiers or literals. Okay, the values of enumeration data type are identifiers or literals. Let us see how can you declare an enumeration type uh, declaration. Okay, I said already how user can declare his own data type. What is the instruction for it? Type. Okay, so start with the type, the word type, type name, syntax it is. Okay, type name is list of values, list of values. Okay, type name is user defined name. So how many values you need to place here. Okay, let us see some examples here. The first example here is type micro operation. Type name is micro operation is, these are the values in the micro operation like load, store, add, subtraction, multiplication and division. So micro operation is a data type which consists these values. That means the object which is declared under this data type micro operation, that object can accept only these values. The values like load, store, add, sub, mul, division. Okay. So similarly, so here is another type declaration is digit. Type digit is values 0, 1, 2, 3 up to 9. That means digit is a data type consisting these values. So the object whichever declared under the data type digit, that object can accept only these values. Those are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That is the mean. Then coming to subtype, you can also declare a subtype. The purpose of subtype is in order to take a part of the range, a part of the range. So the subtype can be represented in three different forms. These are the syntaxes for the subtype declaration. Subtype, subtype name, that is user defined name, is type name. Type name is the, what is the base for this subtype. Okay, base type name or parent type name. Start to end, or other options start down to end, or range start to end. Like that you can see subtype declaration in three different forms. So let us take an example. What is the appearance of subtype declaration? For this, first of all, you need to declare a base type, a parent type. Here type digit is a data type consisting these values. Okay, already we declared in previous slide also the same thing. Now how to derive a sub range, a range of values from the digit range. Okay, that is using subtype middle. Okay, subtype name is middle, is base type is digit. Digit is the base type. From the digit base type we are deriving some range of values, right? Those are 3 to 7. 3 to 7. This declaration is in the this example is reference to first model. Okay, 3 to 7. That means what? Middle is a data type. Middle is a data type which consists values 3, 4, 5, 6, 7 only. That means suppose if any object declared under digit, that object can accept all these values 0, 1, 2, 3, 4, 5, 6, 7 and 8, 9. But if the object declared under data type middle, that object can accept only 3, 4, 5, 6, 7. Okay, so that is the difference between type and subtype. Similarly, the other forms like this. Subtype middle is digit 7 down to 3. In this way also you can declare. Or the third form is subtype middle is digit range 3 to 7. Okay, anyone you can use. Then coming to another data type, that is integer type. Okay, so in the integer type, the values are the values within the specified range. Values may be within the specified range. How the user can define it, you can see through the syntax, that is uh, type index is range 0 to 15. That means index is a data type of integer, it holds the values 0 to 15 only, 0 to 15. That means if any object is declared under data type index, that object can accept any value in between 0 to 15. That is the meaning. Okay, any value in between 0 to 15. Okay. Similarly, suppose if you see the second example, type word length is range 31 down to 0. That means the word length consists the values 31 to 0. Suppose if any object declared with the data type word length, that object can accept any value between 31 down to 0. Okay, that is the meaning. And coming to floating point type, so this is used to declare a real values in the specified range. Okay, like integer. Similarly, this is for real numbers. Okay, let us see the syntax and examples. Type TTL voltage is range 0.0 to 5.0. Okay, that means TTL voltage is a data type which can have the values in the range 0.0 to 5.0. That means if any object declared under the data type TTL voltage, it can accept any value in between this range. Okay. Similarly, this is another example to declare floating point types. Coming to physical type, the values of physical type represents measurement of any physical quantities like current, voltage, length, time, etc. Okay, so let us see the syntax for the how can you declare a physical type is like this. Here with reference to current, one example is presented. Type current is range 0 to 1 power 9 units. The base unit is nanoamperes. The other units microampere, milliampere, ampere, and units. Okay, that is the current is a data type consisting the range of values. This is the range and the units in which nanoamperes, microampere, milliampere, amperes. Suppose if any object is declared under the data type current, that object can accept current value in terms of these units only. Current value in terms of these units. Okay, right? Then coming to the other ones are composite type. In composite type means a collection of values and it is appeared in two forms, array type and record type. In array type, all those collected values are of same type. If the collected values are of same type, coming to array type declaration. If they are different type, coming under record type. Let us see the syntax for the array type. In array type, what is the meaning? All the values are of same type. That is type address word is array 0 to 63 of bit. That means the address word is declared as an array with how many locations? 64 locations. With the 64 locations, each location of which type of data? Only bit type of data. That is all values are of same type of data. Okay, so like that an array type can be declared. Coming to record type, let us see one example here. One pin type declaration is there. Type is integer. This pin type can accept the values 0 to 10 only. Okay. Now record declaration is record size integer range 20 to 200 critical delay : time number of inputs colon pin type, number of outputs colon pin type. That is, size is an object of which data type, integer data type, can accept the values from 20 to 200 only. So this size is integer type of data. Coming to critical delay, this is an object can accept which type of data? Time type of data. Okay, the second object data type is time. The first object data type is integer. Second object data type is time. Coming to third one, number of inputs of type pin type. Pin type means pin type is a data type of like integer. Okay, this is integer data type. Coming to fourth one, it is also integer data type. Like that, different types of data you can observe in the record type. Okay, that is. And coming to access types, the access type declares a pointers. Already you have an idea in the C language or C++ language, pointers. A pointer is used to access the data from different memory locations. Like here is one example, type PTR is access module. That means PTR is an access or pointer holding the address of an object of data type module. Okay, PTR is an access type or a pointer which holds the address of an object. The object is which data type? Module. Okay, so that is the purpose of the access type, and these are the other examples. Then coming to file types. So the file types, how can you declare a file type is with the syntax type file type name is file of again data type. File type name is a user defined name, is file of which type of data. Okay, for example, if you see type vectors is the file name, file type name is file of what type of data? Bit type of data. Okay, so vectors is it is a file type name which can accept bit type of data. Okay, you can use this file type name while declaring the file objects. Okay, so already there we have seen on file object declaration, there we used file type name, used a file type name. Okay, that is the purpose of the file type. So like that, user can define his own data types. Already predefined data types are there. Suppose if anybody want to declare his own data type, you can declare like this different types of data with the command type. Okay, so in next class we can see about the operators.